Okay, so now we should have a good understanding of what a manipulated variable is for this experiment, what a responding variable is, and we should also have a hypothesis. Keep in mind we're studying to see how resistance affects current in a circuit. So let's skip ahead here to this page. The first thing I want to make sure that you have is a title for your graph. Your title should describe what's happening on your y and your x axis. And let's do this as a class 2 for me, please. Let's go ahead and write in a few data points here on the x axis. No resistor, keep in mind that represents 0 ohms. Now let's go ahead and add in just a few more here. How about right here, let's add in 100. 100 ohms. Here let's add in 500. Trying to write with my mouse. Here we'll type in 1,000. Let's type in write in 1K. This should be 1,500. 2,000. 2,500. 3,000. 3,500. And 4,000. And let's throw in one at the end that's really big. How about 10,000? Okay, so we're going to be making a bunch of circuits. A circuit that has no resistance, 100, 500, 1,500, so on. We're going to make a circuit for all of these. And what we're going to do is put a light bulb into that circuit in series, and we're going to judge how bright the light bulb is. And to do that, we're going to be using the website 123D Circuits. Here's how we'll do it. We're going to throw in a 9-volt battery. We'll be using a 9-volt battery for this entire experiment. And we're going to need a light bulb as well. We're going to be using the same light bulb for this entire experiment as well. And we're also going to need a resistor. I am going to rotate this resistor by pressing the R key. I'm going to place it right around here. The nice thing about the resistor is that we can add it any resistance we want in ohms. I'm going to start off with the, let me do 100 ohms. And let's create a circuit. Positive and negative. And then we'll start the simulation. And I noticed that I messed up here, so let's fix this really quick. Needs to be in line there. There we go. And now you ask yourself, is that bright, very bright, dim? Where is it? I'm going to say for me that's probably, I'm going to take one more look at it. I would probably rank that, for me, in my opinion, it's probably right around in here. Now you can go ahead and just continue on with this pretty easily. Let's do the 500 one together. You can stop the simulation and change this to 500. Run the simulation, and you can plot your points accordingly. That's how this whole section works, is with a circuit looking something like this. I'd like to make sure you're using a 9-volt battery and a light bulb. And remember, you can change the amount of resistance just by typing it in pretty quickly like that. So this part should be pretty self-explanatory. Let's take a look at this next page, though. On the next page, first of all, don't forget about question number 4. I want you to take a look at your qualitative data from other groups. You should have a whole collection of points on here and compare that with other groups in the room or other people in the room, and write how similar does your data look, and try to explain why or why not. Don't forget about this question. Also, don't forget about question number 5, where you actually have to create a name for your class or a name for your graph. Right in here, we follow those same rules where you have to have a descriptive title that represents the y-axis and the x. Let's go ahead and write some stuff in here. Let's see, how do I do this here? On here, let's see, I don't know how well I can do this here with my technology I'm using. I'd like you to, it keeps taking me, oh, here we go, this works. I'd like you to throw in plot a few points down at the bottom of this as well for me here. Let's write in 100 ohms, 500 ohms, 1,000, 1,500, which is 1.5 K, and let's jump up to 2,000. Keep in mind that now we are judging the quantitative data. With quantitative data, we're using actual numbers, and we can do that with a multimeter. We're going to be measuring the amperage. We're going to be measuring how amperage is affected when we create circuits of these differing values. In order to do this, we have to throw in a multimeter. So I'm going to go to Components. I'm going to search for my multimeter. You could just type in the word multimeter here. But this is what it looks like. And I'm going to just connect this right into my breadboard. I'm going to delete, whoops, Control Z will undo. I'm going to delete a few wires here. I guess just one wire. And let's put this to 100 ohms. And I'm just going to wire this in series. Again, we have to wire the multimeter in series with our circuit. So the light bulb should turn on when I change this to amperage. So right now it says negative 60.2. I'm going to stop the simulation. We can switch that around pretty easily by playing with our polarity. I'm going to change the positive and the negative wires around. And that should give us a positive number. If you want to, if you get a negative number, you can just disregard it and keep it. It's totally fine. You can't have a negative amperage. So just disregard any negatives. Okay, so for this resistor with 100 ohms, I am getting 60.2 milliamps. Here's what I'd like you to do. Go to your chart, and where you had 100, I want you to plot that point. So for 100 ohms, I'm going to go straight up. That's 20 milliamps. Go all the way up to 60.2, and I'm going to kind of guesstimate it a little bit here. Then I'm going to put a dot there, and most importantly, I'm going to write next to it the actual number. Lowercase m, capital A. I'm going to do that for all of them. All right, that's how you affect it. Keep in mind, you can throw in, I could type in 100,000 ohms and run that, and our amperage gets really messed up. So go ahead and you can easily flip through it just by playing with these numbers. Now, lastly here, before I wrap this up, is I'd like to take a look at these last questions here. Please make sure that for questions number 6, I bolded this in here, your answer should be in the form of an if-then statement. All right, please keep that in mind. All in all, final tips here before you begin this experiment. Make sure to use a 9-volt battery. Make sure that you're using either Chrome or Firefox. Don't use Internet Explorer. The multimeter doesn't work in Internet Explorer. When it comes to logging in for the laptops, I don't know how well you can see this here, but remember, when we log in with the laptops, your username will be this right down here. It's different for every computer on the laptop. So in this example, it would be MSRM116W7 laps, you can write that lowercase, 5, whoops, with a / Arduino. The password is just Arduino, all lowercase. All right? Make sure to remember that. And the last thing I want to point out is to label those data points. So back on this page, make sure that you are writing in that number. I don't want to see just random dots everywhere. Guys, we're looking for really good data here. So thank you so much for listening, and good luck.